Hello everyone, my name is Aya Salama and this is Lab 1 of Physics 2212 Charge Tapes. First we're going to start off with the introduction. So the purpose of this lab is to show how charged objects react using tape, model these results using glow script, and then find gravitational and electric forces and the charges on the tape. Some major concepts that we're going to be using in this lab is Newton's second law, Newton's third law, and Coulomb's law. So then we also know that acceleration for this lab is going to be 9.81, which is the gravitational constant. And then the result of this lab, very briefly, is the excess tape charge is 1.283 times 10 to the negative 8. The charge of the tape of one piece of tape, and both tapes also repelled because they have both positive charges. Now I'm going to be describing the experiment's procedures. So the first thing we did was the U-tape was created, and when near negative charged pen, it attracted to the pen. So the tape B is the system, tape A is the surrounding. The initial condition we had was that tape B is attached to two books and tape A is a distance away from tape B, as you can see in the figure below. Some key assumptions we've made is that each U-tape has some charge, the same charge, sorry, air resistance is ignored, and the tape weighs both 1 grams. And the results of these procedures is the length is 0.2, mass is 0.0002 kilograms, distance is 0.0275 meters, the gravitational force on the tapes is negative 1.962 times 10 to the negative 3 newtons. The excess electric force was 1.962 times 10 to the negative 3 newtons, and the tape charge is 1.28 times 10 to the negative 8. What we found after our procedure was that both tapes had a positive charge, meaning they both repelled each other, because we know the same charge repels. Here is the code for the computational model. As you can see, we have our initial conditions, we have the constants, and yeah, let me just read it out a little bit. So 9 times 10 to the 9th, we know is proton's weight is there and with scale factor, and then negative 9.8 for the gravity. We have the length, width, and a bunch of other factors for the tape. We did the calculations to find the electric force and gravitational force. And I don't think this video plays, but this is a computational model of it. Here's the computational model continued. So what was the magnitude of the charge on one piece of tape as calculated by your computational model? What I found was the magnitude of the charge is 1.283 times 10 to the negative 8. What assumptions, approximations, or idealizations did you have to make to determine approximately the amount of charge on the floating tape? Select all that apply. So from these are the ones that I've selected. 1. Ignore air resistance on a moving object. 2. Treat a long tape as though it were a point charge, with all charge concentrated at the center of the long tape. And then 3. Assume that each U-tape you made had about this, or I made, had about the same amount of charge, evenly distributed along the length of the tape. These are the 3 idealizations that we assumed for the computational model. And here are some questions. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? Nothing will change. The pen would be negatively charged and the tape would still attract the pen, making the tape positively charged. Why? Is it important to handle the charged tape as little as possible? What happens when the charged tapes come in contact with your hands or the objects? The answer to that is that interactions would weaken due to electron transfer that happens with contact. Here's the conclusion to sum everything all up. So the excess charge on the tape was 1.283 times 10 to the negative 8, which was found by using the mass of the tape to find the gravitational force. Using Newton's third law, I was able to find the electric force. Using the electric force and distance between the tape, the charge was found. Thank you guys so much.